Hi everyone. Okay, so to really hit home this idea that an area function is an antiderivative, a big part of your work is just going to be chugging through some derivatives and sometimes rather complicated derivatives of either area functions or area functions composed with other functions. So I like this because it really does force that idea of, okay, this is an antiderivative. And it also goes back to some Calc 1 taking derivatives tricks in kind of a tricky form. So, first one, if we want to find the derivative of the integral from 7 to x of 5 to the t dt with respect to x, what I'm hoping for is you look at this and you say, okay, that is one of the antiderivatives. It's a specific one. There's no plus c on there. One of the antiderivatives of 5 to the t, which means when I take its derivative, I better get back 5 to the t, except that there's this funny variable change, right? That t in there is what's allowing that to be a function, but the antiderivative will not be a function of t, it will be a function of x, which means the derivative will have to be a function of x. At first, a lot of people aren't really comfortable just jumping right to that, but that is the entire point of every problem that looks like this, even if there's other stuff mixed in. The point is if you understand your construction theorem, then as soon as you see this, you know that it's the antiderivative of 5 to whatever variable, so its derivative better be 5 to that variable. So the point is that derivatives and integrals are inverses. They should wipe each other out. If you need to walk yourself through and convince yourself, this one, they aren't all, but this one is deliberately built so that we can do that. So if I want to find the antiderivative of 5 to the t, it's 5 to the t over the natural log of 5. And then I'm supposed to evaluate at 7 and x. So I'm taking the derivative, when I get all done, of 5 to the x over the natural log of 5 minus 5 to the 7 over the natural log of 5. When I take the derivative of 5 to the x over natural log 5, remember that the over natural log 5 part, I really don't want to see you using a quotient rule on. That's 1 over natural log 5 times 5 to the x. Constants just carry along for the ride. So the derivative of 5 to the x is 5 to the x times the natural log of 5. Very conveniently, the natural log 5's cancel. The derivative of 5 to the 7 over the natural log of 5 is 0. That is a constant. There is not a single variable in the second term, which means that all I'm ending up with is 5 to the x. So you can walk yourself through these things. In fact, even if you don't have a function you can find a nice antiderivative of, you can walk yourself through. But again, I would say the entire point of a problem like this is for you to recognize that derivatives and integrals are inverse processes and they should wipe each other out. So we should just get back where we're started. I am going to throw a wrench in things later so that you have to really think about when you'll have chain rules or constants cropping up that you have to keep track of, but that's the big thing happening here. Okay, find the derivative of the integral of function little f of t from a to x. Okay, so again, what I'm hoping is that you see the process here would be take little f, find the integral, then take the derivative. As long as you're finding the integral and then taking the derivative back to back, you should get back where you started. So really, I should just be able to say, I'm going to get back f of x. Again, the only weird thing is the variable change. If you look up at the last part, you can see where that came from. If you want to walk yourself through this, you can. Please work towards not having to. We would first find an antiderivative. I don't know what it is, but I can call it big F. We would then evaluate and then we would take the derivative. We know that when we take the derivative of big F, we get little f. That was the entire reason that I called it big F, was so that I would remember it was the antiderivative. We know that the derivative of big F of A is 0 because whatever function that is, yawning, its derivative, when you plug in a constant, you get a constant, so its derivative will be 0.